Okay guys, I'm not sure if I'm going to like it videoed this way, but we're going to try it, and then I'm going to get your opinion on Thursday. You can tell me what you think, but I have the PowerPoint up here, and I thought I would try going through it since a lot of the graphics are clearer than in the book. And so let's start 2-1. First, we're going to look at constructing frequency distributions for qualitative data, construct bar graphs, and we're going to construct pie charts. So remember the difference between qualitative data and quantitative data. Quantitative you can count, qualitative is in categories like colors like blue, red, green. Okay, so objective 1, we're going to look at frequency distributions. Frequency is the number of times that it would occur in a data set. So a frequency distribution is a table that represents the frequency for each category. So here we have a retailer accepting 4 types of credit cards and lists the types by the 50 customers as follows. So here's just the 50 transactions and what card that they used. And if we break it down and count it, going back, if I take a look at MasterCard, I'm going to go through and count all my MasterCards. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can see then when we come here, that's why the frequency number is 11. Visa, if we count, will be 23. American Express is 9, and Discover is 7. So this is a frequency distribution. Now, the frequency distribution displays how many observations are in each category, but sometimes we're interested in the proportion of observations of the categories, and the proportions of observations are called relative frequency of the category. So what you will do is you'll take the frequency divided by the sum of the frequency to get your relative frequency. If we take a look at the example we just had, if we have 11 MasterCards, we know that we have a total of 50. We were told that in the beginning, and we should always add these together just to make sure that this adds up to 50, and it does. So 11 over 50 would be 0.22, or 22 hundredths. 23 over 50 is 0.46, 9 over 50, 0.18, and 7 over 50, 0.14. Now, these are probabilities. Sometimes you can use this to also get your percentages. So this would just be 22%, 46%, 18%, and 14%. Let's look at bar graphs. Bar graph is a graphical representation of a frequency distribution. It consists of rectangles, has to be equal width, with one rectangle for each category. The height represents the frequency or relative frequencies of the categories. Here's an example. We have the frequency, MasterCard. Here we have 0, 5, 10, 15, 20, 25 alongside. Notice the scale has to be the same in between the numbers, the distance. And then over here, we have our relative frequency, which again is our proportions from 0 to 0.5, or 0 to 5/10. You know, if you want to say the numbers correctly, we should be saying 5/10. And notice that the scale, the distance between each one is the same. Now, when you take a look at these, you'll also notice that they look similar in nature. It's just because our scale over here is in relative frequency, and this is in frequency, which is actually how many, that the numbers are different. But as long as you keep your scale the same between the two, the distances between the two the same, you're going to have bar graphs that look the same. A couple other things I want to point out is in a bar graph, you do not allow the bars to touch unless you're comparing two different things. Okay, and we'll take a look at that in a minute. So the bars do not touch. You might say, well, how do I know what width to make it? You just make it pretty. Make it however you want to make it for a bar graph. There is no rule on how wide to make your bars for the bar graph. Okay, Sometimes it is desirable to construct a bar graph in which the categories are presented in order of greatest to least. So you're just reorganizing him. Let's go back here and look at this. You see Visa is the first, MasterCard's the second, American Express the third, Discover the fourth. So the only difference is we're moving them around, and we can because it really doesn't matter what order that they're in. We don't have a specific order at the bottom that we have to follow. Now you can do it horizontally as well. Sometimes we'll do horizontally if we have long titles so that we can just read them like we normally would read them. And then we would put the frequency or the relative frequency on the bottom. This is a side-by-side bar graph, and this is where you're going to compare two things in the same category. So here we want to compare, let's see, we have Facebook, we have two different things. We have in 2015 is the pink, 2016 is the blue. We want to compare the difference in each one of these next to each other. So that is the only time that you're going to let bars in a bar graph touch, is when you're comparing two, in this case, two different years, or you might be comparing two or even three other categories, usually not more than three though. Okay, so we have Facebook, Gmail, Instagram, LinkedIn, and Twitter, both from 2015, 2016, and we're comparing them side by side. Objective 3, we're going to take a look at constructing a pie chart. So a pie chart is just another way of displaying a graph. The key here is you have to remember that a circle is 360 degrees. And we're going to want to take a look at each one of these categories and figure out what angle we would have to use to create the correct scale to show our pie chart. So the relative size of the sectors match the relative frequencies of the categories. So if the frequency is 0.25, then it takes up 25% of the circle. Okay, so here we have 22%, 46%, 18%, and 14%. So you might say, how do we do that? Well, let's back up. I thought they were going to show you how to do that. So I'll show you how to do that. So you would take 22% of 360 to get your angle for this. Then you would take 46% of 360 to get your angle for your Visa, and 18% for American Express, and 14% for Discover. And then when you construct this graph and you're going around and measuring these angles, it should all come together as 360 total. So if it doesn't, then something's wrong. Okay, how to construct a frequency and relative frequency distribution. We're going to look at Pareto charts, bar graph with horizontal bars, and a side-by-side bar graph. So how to construct and interpret the pie charts. All right, now that's the end of 2.1. Now we're going to go to 2.2. In 2.2, we're going to look at constructing a frequency distribution for quantitative data. Now remember, quantitative is where we measure the data. We're going to look at histograms, which are similar to bar graphs, but also very different. And we're going to determine the shape of a distribution from a histogram and construct the frequency polygons and ogives, which are sometimes used. Okay, first, frequency distribution for quantitative data. Here we have a summary of quantitative data, the frequency distribution just like we did for qualitative data. However, we're going to have classes. So the classes have to be the same width. So from 0 to 4, if it includes 0 to 4 would be 5. Then including 5 to 9, including 10 to 14, including 15 to 19. So the class width here would be 5 for each one. And these class widths have to be the same. Okay, equal widths that cover the observed data. Now the lower limit is the smallest value that could appear. So the lower limit here is 0. The upper limit is the largest that could appear in that class. So my lower limit of my first class is 0. My upper limit is 4. Then my class width is what's between, which is 5. How many? And again, you can count 1, 2, 3, 4, and 5. Okay? All right, so guidelines for choosing classes. Now, whenever you have a whole lot of data, the objective in developing any type of display or graph is to make it look nice and appealing and easy to read. So each observation you have to make sure is included in one of the classes. You also have to make sure that the classes don't overlap. So in other words, I can't have from 0 to 9 and then from 8 to 12 because it would overlap. The classes always have to be of equal width, and there can be no gaps between the classes. Even if there are no observations in a class, you have to include it in the frequency distribution. So if I have 0 to 4, 5 to 9, 10 to 14, even though I might not have anything between 10 and 14, I still have to include it in my graph. So here are the step-by-steps, and you will have this PowerPoint, or you do have this PowerPoint underneath your lessons on Sakai, so you can pull this out and print it, and that way you can use it when you're doing your homework. First, you're going to choose your width. Now, it is good practice to make sure you have around, and I say around, 10 bars when you're doing a histogram or even a bar graph. You don't want too many because then it looks too cluttered, and you don't want too few because then it won't give you a good picture of what you're looking at. So around 10. So you might say, well, I can't really do 10 with this, I can do 13. Well, it's still around 10. So again, you want to make it look nice. So we're going to first of all choose our class width. Then we're going to choose the lower limit for the first class. Should be a convenient number that's slightly less than the minimum data value, or it might be the minimum data value. Then you're going to compute the lower limit for the second class by adding the class width. And you're going to continue this along the lines, compute the lower limits for each of the remaining classes by adding the preceding class, and then stop when the largest value is included in a class. Count the number of observations and then construct the frequency histogram. So here we have something interesting where we have 65 emission vehicles and units of grams of particles per gallon of fuel. We're going to construct a frequency distribution. The first thing that I do when I'm looking at this is I'm looking for the smallest number that I have. And so far I see that I have a 0.86. Let's see if we can find small. There's 0.55. See if we can go smaller than 0.55. 0.25 is here. So it looks like 0.25 would be my smallest number. And then I want to take a look at my largest number, and I see a 594 here, 664. Anything bigger than 664. Let's take a look through here and check it out. Anything bigger than 664. No, this is 655. Still smaller. Okay, no. So my highest one is 6.64 and my lowest one is 0.25 if I didn't make an error. So I want to figure out how many bars I could make between 0.25 and 0.94. And again, I wouldn't want one bar. I wouldn't want to go from 0 to 1. That doesn't make any sense. But I want something that's going to show the distribution and not be too cluttered. So let's see what we can do here. Okay, so the smallest value is 0.25. So we're going to choose 0 for the lower limit. The class width is 1 and the lower class limit is 0.00. So the limit for the second class is 1. So we're going to go from 0 to 1. So these would be my widths. 0 to 1. I would have my next lower limit would be 2. My next one would be 3, 4, 5, 6, 7. This would give me, if this is my first one, this would be 1, 2, 3, 4, 5, 6, 7 bars, which again is around 10. So this includes my largest value, so I'm going to stop right here. So this is how then I would construct my chart. I want to go from 0 to 0.99. Here again are my lower limits that I just figured out. Okay. Now let's say you do this and you only have about 4. Well, then you might want to cut them in half so that you can have 8. Okay. Let's say you do this and you have 20. You might want to double them up so you can have 10. So you have control over the width of these classes. All right. Now we're going to go through and take a look at this chart, and we're going to count how many that we have in each one of those classes. So let's first take a look between 0 and 0.99. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I counted 9. Did I go past it? Oh, no, I'm going backwards. Whoops. Sorry. Let me go back forward. I hope I'm not making you dizzy. Okay. So here we have our 9 frequency of our class. And then we continue through the same process to get all of our numbers. Now, a couple things I want to point out. Notice this is continuous. There are no gaps. This is really between 0 and 6.99 without any gaps. Okay, now you might say, well, technically we could say there's a gap between 0.99 and 1. Well, what I'm talking about is if we round to the hundreds, which is what we obviously decided to do here, there's no gap between 0 and 6.99. Okay, so let's take a look at the next step. Now, the relative frequency would be dividing the number by how many total. So again, you take the frequency divided by the sum of all the frequencies together, and then that will give you your relative frequency. So here when we add this up, let's add it. We have 2, 3, 6 would be 9, 19, 20, 30, 56, and looks like 65. So we're going to take this and we're going to divide this number by 65, this number by 65, this number by 65, etc. to achieve these numbers over here. Once we do that, we are now ready to construct the histogram. So we have the frequency distributions, or as we say, the relative frequency distribution. We can put the information in a graphical form by constructing this histogram. Notice the difference. The difference between a histogram and a bar graph. The bars on a histogram touch. Why? Because it's a continuous interval across. There should be no gaps unless there is no data in one of the classes. Sometimes you'll have gaps then, but you're not just going to have a gap for the sake of having a gap. Alright, so here we're going to take our class width. Notice also that these widths are the same when we draw them. So you want to make sure that they look nice and that they're all the same. And then this will be your frequency or your relative frequency, whichever one that you use. Okay, So here are the frequency histogram and relative frequency histograms for the admission data. Notice again, they have the same shape, okay? They have the same shape because the ratio differences are the same between them. This one is just frequency, giving you how many times. This is a relative frequency, giving you the probability, or if you move the decimal over, the percentage. Notice again, there are no gaps between the bars on the bar graph besides a tiny little line that they just want to emphasize here. So there you go, and that's it. So again, there's no hard and fast rule for choosing a number of classes. So in general, it's good to have more classes than fewer, but it's also good to have reasonably large frequencies in some of the classes. So here are 2 principles that they suggest can guide you. Too few classes will produce a histogram that lacks detail. It won't give you enough detail. And too many will produce a histogram with too much detail that mainly features the data and it can be obscured. So I like to keep it around, again, I said 10. But again, if you have a lot more data, you might want to go with 15. Here's an example. Here's where we have a whole bunch of tiny little widths. Okay, we get this little jagged appearance, and these look like lines. We have one, and this little gap is a class 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like we have, maybe 50. I don't know. There's a whole bunch of them here. Way too many classes. Doesn't give us a pretty picture at all. Over here, we only have 4 classes, and it just basically gives us the most basic features of the graph. You can see this gives us so much detail. This gives us not enough detail to really tell what we're looking at. Alright, now you can create a histogram for emissions on your TI-84 Plus. You're going to enter the data into L1, your list 1 on your graphing calculator. Then you'll press second Y equals, then 1 to access the plot. Select on and the histogram plot type. You can press zoom 9 to view the plot. So here you go. Maybe you might want to try that out. Okay, sometimes you might have an open-ended class, and this happens, for instance, this talks about age. So if we have ages 5 through 14, 15 through 24, notice that all these class widths are the same. However, when we get down to 85, we only have 85 and older. Okay, so it's an open-ended class width. Now, this could happen for a number of reasons. Maybe there's only a few in here. Obviously not the case here. Maybe the researcher is more concerned about grouping the ages, and 85 and older are considered elderly. So that could be the reason why. And when you have something like this in an open-ended class, a histogram really cannot be drawn with this because you have no width. So now we're going to talk about discrete data. If you remember, we talked about discrete already before, discrete and continuous. Discrete means that you can actually count or list what you're talking about. So when data are discrete, we can construct a frequency distribution in which the possible value of the variables form a class. The following table and histogram represents the results of a hypothetical survey in which 1,000 adult women were asked how many children they had. So here are the results. We have how many children do you have? They asked 1,000 adult women. These were the results, and here is the histogram. Determining the shape of a distribution from a histogram. The whole reason that we do graphs is to give a visual impression, and when we're using a histogram, the impression of the shape of the data set will tell us information about how the data works in that situation. So statisticians, of course, develop terminology to describe some of the commonly observed shapes. It is symmetric if it pretty much can be split down the middle and it looks symmetric, does a mirror image from left to right. Now, you're rarely going to have something that's perfectly symmetric. So you want to say that it's approximately symmetric. So a histogram is symmetric if pretty much it looks like it's mirrored from the left to right. So you don't have to worry about it being perfect. It can be approximately symmetric and still called symmetric when we're talking about histograms. Now, whenever you have a histogram like this and you can draw a curve over it, and the lower end is, if you would set your right hand on the lower end, then it would be skewed to the right. Or they also call it positively skewed. Okay? If you have a histogram where the lower end is to the left, and you're putting your left hand on the lower end, it's on this side, then it's skewed to the left, also called negatively skewed. Now, the peak or the high point of a histogram is referred to as the mode. And a histogram is unimodal if it only has one mode. It has bimodal if it distinctly has two places that are higher. So this is unimodal, this is bimodal. Unimodal is the one that you will see the most. Bimodal is not as common. Usually if something turns out being bimodal, then you might want to consider changing your graph, because you might have things that are mixed up a little bit, and it might require two graphs to really give the proper picture. Alright, we're going to look at constructing frequency polygons and ogives. So some graphs are used to representing frequency or relative frequency require class midpoints. Now you remember, if you want to find the midpoint of something, you add the beginning and the end together and divide it by 2, and that'll give you the middle. Same here. So here you're going to take your class midpoint, you're going to take your lower limit plus the lower limit of the next class and divide it by 2. So your lower limit plus the lower limit of the next class and divide it by 2, and that will give you your class midpoint. So here's what we looked at before. We have from 0 to 0.99, but again, we're taking 0 plus 1, the next lower limit. So 0 plus 1, then divided by 2, 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5, and then 5 plus 6 to get this one. Now the last one is going to be 6 plus 7. You might say, well, I don't have 7 as a lower limit. Well, if we would have another class, it would be the number 7. So we're smart enough to know that we can just use the number 7 there. Once we do this, and we go back and look at these numbers, we have 0.5 clear down here through 6.5. These are our midpoints. These are our frequency numbers that did not change. Okay, it's the same as before. So now I'm going to be doing a line graph where I plot these points: 0.5 and 9, 1.5 and 26, 2.5 and 11, etc., 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 etc. And then I connect these. This is called a frequency polygon. Why is it called a polygon? Well, probably because we are connecting the lines together. I know it doesn't connect all full circle in the end, which is what we would consider a polygon, but they probably looked at the idea and said, similar to a polygon, we're going to connect the dots as we go from smallest to largest. So a frequency polygon it is. Now cumulative frequency is another thing that might be asked for in the classes, is some of the frequencies that add all the previous classes. So here are your frequencies. Your cumulative frequency, this one would be 9 plus 26, you'll get 35. The next one would be 35 plus 11 is 46. 46 plus 13 is 59. 59 plus 3 is 62. And you continue on, and that will give you your cumulative frequency. Notice that is continuing to get larger and larger. Also notice that the bottom number is the sum of what our frequencies added up to be before. Now an ogive is constructed by plotting a point for each class. So the x-coordinate of the point is the upper class limit, and the y-coordinate is the cumulative frequency. So an ogive uses the upper class limit, and I'm going to go back so we can look at that again. These are the upper class limits right here. So they're going to use these and the cumulative frequencies. So here are our points that we're going to plot for our ogive, and then connect them together. So you should know how to construct a frequency and relative frequency distribution for quantitative data, how to construct and interpret histograms, the guiding principle for choosing the number of classes in a histogram, and again, my advice is to keep it around 10, how to construct a histogram on the TI-84 Plus calculator, and then some possible shapes, looking at symmetric, skewed to the right, skewed to the left, and then what unimodal and bimodal is. And finally, how to construct a frequency polygon and ogive. Okay, well guess what? That is it for today. So or not for today, but for the first two sections, I will be making 2.3 and 2.4 next, and I will talk to you soon.